Assalamu alaikum. In this lecture, we'll talk about linear array of two kinds of atoms in ionic crystal. Here we have an array of atoms. The dark one has mass M capital and the light one has a mass M small. We have to find the dispersion relation for such a system. The separation between two adjacent atoms is A. This is the equilibrium separation. Now the equation of motion for the small mass M. The small mass M interacts with the nearest neighbor atoms, this big M and this one to the left. So as we know from the previous example or a previous lecture, the equation of motion is given by this my double dot 2r is the labeling or the 2rth mass. This is the labeling for the mass. T over A represent the stiffness in this case. Y of 2r plus 1 plus y2 of r minus 1 minus 2y sub r. Similarly, for the equation of motion for the M capital mass is given by this equation. Now the solution we are looking for is of this form. Y sub 2r is some amplitude exponential I omega t minus 2 r ka, where 2 ra is represent x here, and for 2I r plus 1 is you have to add here 1. So we get this expression for y. And then we have to find the first derivative and second derivative, so substitute here, and similarly for the y double prime sub 2r plus 1. So doing so, for the first one we get this equation. I label it as equation number 1. The second equation, now also substitute in the second equation and simplify algebra, we get this equation. Now we have two equations, two homogeneous equations. In order to solve them, the determinant must be 0. In this case, the determinant is given by this expression. Omega 2 minus 2m is this part, and this is the second part. Note here A sub m is the amplitude of the small mass, and A sub m capital is the amplitude of the capital mass. So this is the second term. Now for the second equation, it represents the second row in this determinant, which is this is the first one because it's corresponding to A sub m small, and this guy goes here because it's corresponding to A sub m capital. If we put a vector here, A small, A m capital, we get the same two equations. Now solving with this equation, we get the dispersion relation, which is given by this expression, omega square equals such t over A onto 1 over m plus 1 over m plus or minus t over A square root of this thing. We have two roots here. The first root, which has the minus sign, is representing here in this figure. This is omega versus k. It's called acoustic branch because the frequencies occur in this spectrum. And the second root is called the optical branch, which has the the plus sign. So omega square with the plus sign is the upper branch. Omega square here with the minus sign is the lower branch. Now to find the values of this omega at k equals 0 for the lower branch, the first one is 0, and then if you substitute here k equals 0 and take the minus sign, sine 0 is 0, so we get this expression. Omega square minus plus is 0 to 2t over a onto 1m plus 1 over m capital. So this guy is square root 2 over am, and this thing, this when you take the plus sign, you get this guy. So we have two roots, 1, 2 at k equals 0, and here I'm considering m small is greater than m capital. At the zoom boundary here, we have to substitute. Instead of k pi over 2a, we get two things, one from the lower sign and the other from the upper sign. The lower sign, it's if you look, it's divided by m small. The upper sign is by m capital. Now we have 4 points. This is the calculations. Now let's see the behavior for small k for both branch, caustic and optical branch. The plus is for the optical branch and the minus is for the acoustic branch. Let's take the root and simplify it. We substitute here, instead of sine Ka by Ka, because sine Ka is small k is Ka. So we get this expression. Simplify this, we get this. Finally, for the lower branch, we get this value. So omega square is proportional to k square, or omega is linear in k for small values of k, and that's for acoustic branch. Now for the optical branch, for k equals 0 or long wavelength, we have to substitute in equation 2 for omega square. K is 0, cosine 0 is 1, and omega square at k equals 0 is given by this expression. You substitute here, then you find the relation between a sub m small and a sub m capital. Doing so, we get this expression that a sub m small over a sub m capital is has a negative sign. That means the atoms vibrate against each other. So here you see that the dark atoms and the light atoms, they are vibrating against each other. So the atoms vibrates against each other, with center of mass of ionate cell remains constant. This motion can be generated by the action of electromagnetic wave when alternate atoms are ions of opposite charge, and hence the name of optical branch. Now for acoustic branch at k equals 0, again we have to substitute in equation 2 omega at k equals 0, which is 0. We get this expression. It means that a sub m small is the same as a sub m capital, which means that these atoms are in phase. So atoms and their center of mass moves together as this. It looks like longitudinal waves. This is the case for acoustic branch. Thank you.